Be using multi-node cluster. As the name says, multi-node cluster will be having multiple nodes to communicate within our services: name node, data node, secondary name node, resource manager, and node manager. This is 5 daemons. So using JPS, we have seen it already. What is the use of these daemons? Now, there could be two different types of multi-node cluster. First, first is standard one. Standard means I have one master and n number of workers. And second one is HA, high availability. Now, what is the difference between standard and HA? Now, in HA, I will not be having one master. I'll be having multiple master. Again, we'll use Dataproc, GCP Dataproc to get this, to create the cluster in less than 3 minutes. 3 master and n number of workers. This is more suitable in production, and this is what we use actually in environment. But this is very similar as standard one. Only the difference, I have just one master. Okay. What can be the problem if you're keeping one master? Which means you have one node. So let's say this is your node. And in this node, you have installed all your master services, such as name node, secondary name node, and resource manager. So all these 3 master are in single machine. Then for slave, I have multiple machine. This n can be anything: 3, 4, 5, 10, 20, based on the data volume. So let me create 4 data node and node manager just to satisfy the replication factor and multi-node concept. So I have data node 1, node manager 1, data node 2, node manager 2, data node 3, node manager 3, and one more I have, data node 4. So I'm just keeping 4, okay, because I feel this is my standard cluster environment. If I have more data volume, I can increase this. I can do commissioning and decommissioning. So commissioning means aiding the slave, and decommissioning means removing the slave. Now question here, what if this machine goes down? So if this machine goes down, your all the master services down, and then you will face this error. Actually issue. You'll face downtime issue if this is down, right? You'll have to wait for 10 minutes, 20 minutes, 30 minutes. So if in real time application, if you think this way, right? Let's say Paytm or any internet company who are into multiple production center. So let's say Amazon.in, right? Amazon.in is suppose working in such kind of environment and having just one machine for master to communicate. And if this is down, so if 10 minute their service is also down, you can understand the number of losses of their revenue. What can be the total loss if their server is 10 minute down? So you won't be able to visit to the site, you cannot purchase anything, you cannot use a payment gateway. So many issues can come, because this, best of my knowledge, Amazon.in is having across the globe is 2 million customer. Now 2 million customer, if 10% customer are also visiting, so they're losing 20 million customer almost. And 20 million customer payment, their purchase, their product. This is why this companies in production center, where they are having multiple services opened in different country, they use with HA. Maybe if I have just one or two service location in India, then I can still use this as standard. But if I feel that I don't need even a single minute of downtime, in fact single second of downtime, then I will use HA. What HA says, HA will create your cluster like this. First one, it will create active name node. Then standby name node. I'll visit this part. Okay, I'll tell you the architecture of HA when we see specifically yarn. So currently we are setting the cluster. Once cluster setup is done, we'll go through the concept of HA, that how HA architecture can be built. SBNN, standby name node, active resource manager, and standby resource manager. Now you're thinking, where is data node then? Data node is optional, guys. In this situation, where is the secondary name node if you're thinking, right? This one, this service. This is optional in HA. If I need it, I can create it. If I don't need, I don't need it. So when this active is getting down, standby can take all load and balance the cluster. So all the communication which is going to active name node by client by data node, this will start redirecting towards standby name node. The same thing will happen with this active resource manager also. The moment this gets down, within a fraction of second, my standby resource manager will up. This will start. Okay, so this is what high availability concepts is, that we will not face any single minute of downtime, and worker number of worker can be just like this: dn1, nm1, dn2, nm2, so on, based on the data volume. So always you define data node and node manager based on the data volume. And if I remember, I have told you guys there is one formula, right? So we'll come to that formula. How can we calculate the volume of data using the formula? Now let's go and see this is standard one in GCP cluster, how we can create a multi-node cluster. So I've already logged in my GCP account. Go to again big data, Dataproc, clusters. So once you get a good hands-on in single node cluster, okay, you guys are already practicing, I know. Once you get a good hands-on on single node cluster, you should start working with a multi-node cluster. This is what is a production environment. So you'll have actual feel of prod. And the problem with a local machine, okay, in local machine you can create a limited resources. If you have 8 GB RAM in your system, or 10 GB RAM, or 16 GB RAM, this is in local machine. This is your RAM configuration. Now, what do you think? How many node you can create if you have this? If you have this configuration available, hardly in this 8 GB you can create 3. Also with very low RAM configuration. Master you will have to give more because master needs some more RAM. Slave you can give 2. So if you're doing this, you need at least 8 GB RAM in VM. Okay, this is not total RAM I'm saying. This is a VM RAM. Then 10 GB RAM you can create 3 to 4 machines. Then 16 GB RAM you can create maybe 4 machines. So you cannot create n number of machine and you can try it, because in local you have a limitation, but in cloud we don't have any limitation. This is why we are preferring cloud to create a multi-node cluster especially. Now my cluster name is some by default name is there. I'll leave it as it is. Reason. So we're sitting in Maharashtra, Pune. So it comes with Asia South one. Okay, Asia South one is our region. This is a Mumbai region, by the way. We don't have any. Let me see. Do we have any central location? So US Central one. If US Central one is there, I can Google it up here first. US Central one region of GCP. So whenever you want to search anything, you can get that name and get the central region. They will tell you this is located in which part of India. So let me see if it is available in Pune. We'll select it. Asia South one, you can see it, this one. This is Mumbai. ABC is my zone. I can pick up anything. I think in India for free services we have just this. Pune we don't have such. Central is okay. So this is US Central, by the way. That's my. I thought it's Asia Central. Anyway, I'll keep I'll keep this Asia South one. And why we are doing this? In AWS also we have selected Mumbai data center just to decrease our communication, right? Otherwise my communication time and network traffic time will be very high. Cluster mode. So single node cluster we have already tried last time. We have two options, a standard and high availability, right? Since this is not a production cluster, I'll create a standard one. If you know a standard one, you can create a high availability also. This is the concept of high availability. Then what is the configuration of master machine you want to give? Configuration of master node, it's written here. Then contain the yarn resource manager, HDFS name node, and all job drivers. Series N1. Okay, there are N1, N2, N3, ED. I think for free they have N1 and E2. Let me see it. This is a type of processor which Google has. So I'll keep the by default one only, N1. Machine type. What configuration you want to give? RAM and CPU. So this is the option. 3.75 GB is a minimum RAM, and if you see maximum, you can see it. 360 GB memory. This is a RAM and this is a number of CPU. This is very high, very big configuration. Okay. So do not use the 360 and 96, because what will happen, your free trial services will complete very soon. Okay. So try with 7.5 GB, which we can, because we just want to see how multi-node cluster works. Creating more configuration is not our task. CPU 2 and memory is 7.8 GB. Minimum I'll keep this hard disk 15 GB. And primary disk type, there are two different options, HDD and SSD. Hard disk and hard drive and solid state drive. So this is a magnetic storage. This is a little bit fast storage compared to standard one. I'll keep the same by default, standard one. Your master node configuration is done. Then slave node. So let me write it here in master node what we selected. So in master node we are creating one master, and this is 7.5 GB RAM and 2 CPU. Then we will create 4 slaves, okay? And why I'm creating 4, just to tell you guys that how actually replication works, how distribution concept works. This is the reason I'm creating 4, otherwise I would have created 3 or 2 also. In slave, I'll give this configuration 3.5 GB RAM and 1 each CPU, virtual core processing unit. So if I have 4 slave and 1 vCPU, so total CPU available 4, 1 into 4, and total RAM available 4 into 3.5. Roughly they'll give me 12 or 14 GB RAM. Let's do that. So this is written as worker node. You can read it here. N1 I'll keep the same. This I'll create as 3.75. And number of machine. Hard disk also 15 GB. Number of node is 4. That's it, guys. So once you fill this all the information, I think hardly it took us 2 to 3 minutes, and we'll hit on this button, create. This will take 2 to 3 minutes and my cluster will be spinned up. So we'll wait to see this cluster. Once this is up, we'll start practicing and testing how this can work actually. Okay, so to see how many nodes are there, I'll go to VM, and within VM I'll click on the second option, compute engine, VM instances. Now, first you can see this is my master node, and these are my slave nodes: slave 1, slave 2, slave 3, slave 4. First, I'll open master. So to open this master, you just need to click on this SSH option. Type sudo jps to see number of services. All those services, these are masters, right? I'll tell you what is job history server. When we talk yarn, I'll tell you what is application history server. There is one more service which is not listed, application master. Now, can I run Hadoop command again? hdfs dfs -ls and slash. In yarn, we'll see this job history server and application history server. What is the use of it? Okay, because currently we are not processing anything. This all the part will come when we process. I have not yet discussed about resource manager. What is a node manager? I'm not yet discussed all these options. So this all option will come in process. Still, we are talking about a storage, how our data can be stored. Okay, so just wait till the time we do not start the storage. Sorry, processing area. Once processing part is done, now we'll see the services. So I can copy any file from here now. Let's say I create a local file. Okay, I create a file. Let me download a file from Google. Or for first, I will check. And for your information, guys, this GCP is by default using a replication factor of 2. This is a by default value. If I want to change it, I can change this number from 2 to 3 or to any other number. Okay. Sample.txt. So we'll say here this is dataproc cluster with standard series of n1. Okay, I'll write some information. Enter Control D. Sample.txt is there. Now we know the command to copy this file. We'll use hdfs dfs minus put, then sample.txt and slash. This data will copy in hdfs. So if you know, I'm following this flow. I have a client, and from this client I'm communicating to name node. The name node is giving me all the location of data node, dn1, dn2, dn3, dn4. Currently we have 4 data nodes. Okay, I'm just trying to replicate the multi-node cluster. Now this client is having a file which has a size of 59 bytes, very small file. So client is having a file, name is sample.txt. This is the name of file. Client requested to name node that I need data location. This is a request. The name node will provide one acknowledgement or response, you can say. Based on this acknowledgement, then and how name node knows which data node is in the near location, we know that name node is skipping all the metadata file. Okay, name node is skipping all the metadata file, fs images and edit logs especially. Then client will write this information to dn1. Let's say this is the nearest machine from the client. How many blocks it will create? Since the file size is less than 128 MB, this is in bytes, it will create a block here. And then replication factor is 2. So this data node replication factor is 2. So this data node will replicate it one more time in any of this machine. Let's say it is replicating to DN3. We'll go and validate which machine is actually holding this data. DN3 is having A. Once this communication happens, what happens? Then DN3 will acknowledge back to DN1, yes, the block has been copied successfully. Then DN1 will acknowledge back to client that we have copied this to block. Okay, and simultaneously they're communicating to name node also using one method, and that method we call as a heartbeat, which happens in every 3 seconds. Now I will see this data from anywhere, because what is the HDFS directory? HDFS is known as a centralized repository. What does this mean? I do not have data available. This A and A block I have only available in DN1 and DN3, but I can access this file from any of this machine. That's what is a centralized repository means. Because HDFS is nothing but it's a combination of all the data node. It's a combination of your DN1, DN2, DN3, DN4. So if I run this command, HDFS, I'll prove you after this, HDFS DFS minus ls and slash. Now when I run this command, so I can list this file from anywhere across the cluster. I have 100 node, I can list this file from 100 different data nodes. Okay, because internal SSH inbuilt communication is already there. Master is taking care of it, but locally this data is stored in DN1 and DN3. Both thing will check. We'll run this command and we'll check in local location also. In local, if you remember, we set this property in HDFS site XML. So let's go there and see where actually this data will store. I'll run this command. List out my file using ls. You can see that sample.txt is here. Now can we read this file also? HDFS minus cat sample.txt. Now we'll identify this data is stored in DN1, DN2, DN3, DN4. And in order to check that, I will again go back to my monitoring environment where I can monitor my cluster and open one by one all the slaves. This is slave 1, this is slave 4. So it started from 0, that's why it is going till 3. Click on this SSH. And this is all configuration files. Okay, if you want to see the configuration where this all the file is stored, you can go to user lib Hadoop, and within Hadoop you'll find etc Hadoop, cd etc Hadoop. This is the location where you have all your 5 files, 5 configuration file: core site XML, HDFS site XML, yarn site XML, map rate site XML, Hadoop env.sh. All these files are already set. We're not setting it up. This is my slave node. Can I run this command to check? Since this command is centralized repository command, I can check it from anywhere. But data is locally stored in configure in this file, user lib Hadoop. I'm directly going there now, etc Hadoop, and opening my hdfs site.xml. If I scroll down, you'll read this property, what this property is talking about. So this property is saying that dfs.datanode.data.directory, this is the name, and where my data will store. My data will store in this location of local Hadoop DFS data. So we need to go to this directory. This is the location where my actual data will store. Okay, so :q cd. You cannot directly access this folder from here. You'll have to type sudo su super user. So once you type sudo su, you go to super user. Now you can go to your folder cd Hadoop DFS data, cd current, cd bp. This is a block pool. Inside this again I'll have current and finalized, cd current. So this is all known to us. We've already done this in single node also. Finalized, cd subdirectory lslrt, and again cd subdirectory. Clear the screen and type lslrt. Do you have any file of 59 bytes, I believe? What was the size of file? Again, we'll verify here. hdfs dfs minus ls slash. This is the size of file, 59 bytes. Do we have any 59 bytes of block here? You can see this 2 blocks is there by default, but none of the file is having size of 59 bytes, which means one thing is clear, that sample.txt is not stored in this machine. It's not stored in this machine. So I'll just cross mark and remove this a block. Similarly, I will check my second block, second data node, whether this file is available in that data node. So again, click on SSH. Likewise, I'll check for all the data node one by one. Once this is ready, again sudo su. Now we know the location, right? If you again want to go, this is the location where your file is stored. This is a standard location, user lib Hadoop. That's why we also created inside user lib. Now I'll directly go to root user, super user, and access my file cd Hadoop dfs data, cd current, cd bp, cd current again, finalized. I'm directly going now since I remember things. Cd subdirectory and subdirectory. So if you do not remember, just use double tab. Automatically it will list down all the folder. 59 bytes. This looks like my data actually stored in dn2, but will not assume anything. We'll test it. When I cat this block, then it says me, hey, this is data proc cluster, the same information which I have copied from local to HDFS. Which means one thing is clear now, that one block A I have here present. This also I'll just remove for now. Similarly, check for third machine and fourth machine. We'll go a little fast now since we're doing the same thing again and again. So what directory currently I'm checking in dev environment, you can check this, but in SIT in production, you cannot check this folders. You can only run this command. You're eligible to run this command hdfs dfs -ls and slash. So I can see this file from anywhere. That's what I said. Centralized repository means, right? Open your, this is my second machine. Sorry, third machine, third worker node, W2, super user, CD Hadoop DFS data, then current, then BP, then current again. So that's what I'm saying. If you do not remember, let's say you just type 2 times tab. This is listing you. Now take current, finalized, subdirectory, LSLRT. 59 bytes. Yeah. So we have 59 bytes here. Now how this they have selected, why name node has given this to address, this must be based on the network information, that how which machine is near from my master machine. If I get this information and paste it here, so this is my data file. So from this we have validated that my block A is replicated 2 times because replication is set as 2 in cluster, and it is present in DN2 and DN3. If you want to check in DN4 also, I'll do that, but I'm sure that DN4 is not having any data. So this is a standard procedure to check and monitor this information. I can monitor this using, if suppose I'm using Cloudera services, there is a Cloudera manager. If I'm using Hortonworks, there's a Ambari. But problem with the Cloudera manager, they do not open in a less RAM like 8 GB, 10 GB. They need a 16 GB and better RAM. But this there I can create any number of RAM, so I can use my Cloudera manager here. What I can do actually, I can create a vanilla machine here, and vanilla means plain machine, and I can set up my own cluster of Cloudera. So I'll share that file if you guys are interested. I have steps written already for Cloudera also. You can test it in your local plain vanilla version. Sudo su cd hadoop dfs data current bp current finalized subdirectory and subdirectory. Do you have any 59 blocks here? This was already clear, but just in order to check, we came to this folder. Now, I have another requirement. I'm saying I want to increase my replication factor. And can I see that file from here also? This will work here also. But data locality is only present with two data node 2 and data node 3. Which means if I want to process this file, the moment I start thinking I need to process this file, this sample.txt, so I have my node manager running in this machine also. If you want to check that, sudo jps. So when you type sudo jps, you get data node and node manager. Now node manager is set up in this machine. Node manager is set up in this machine also, third machine and fourth machine, right? Now where my resource manager will process this block A in which machine using node manager 1, because all this machine has one CPU, right? This has a one CPU, this also has a one CPU, though this is a vCPU, virtual core processing unit, one CPU. When I submit a when I submit a jar file to process this using IntelliJ, then what do you think? It will process in this DN2, DN3, DN1, DN4. Obviously, they will use the concept of data locality. What is a data locality concept? If I submit to process, if NM2 is reading the data from DN2, reading this A from here itself, and after reading, they're following through some of the concept of processing and writing the final output again here. This will be closer or time will less, or this machine will come here first. Since this A is not available in this machine, so this machine will come here, pull the data, take it here. So this is first communication, this is second communication, and process it, and then again write back that output to here. So this is time taking business, guys. This is time taking business. When CPU is not available here, then this kind of communication starts. But if CPU is available, enough number of CPUs available here itself, then this node manager will process the data which are present in DN2. And similarly for all the nodes. So always they prefer data locality. If it is available in local machine, they read data from there itself. If it is not available, they read it from other machine. Pull the data using HDFS SSH concept and process and write back. But in this communication, my time will be high. My time is directly proportional to high execution time. Execution time will be very high, and it will take a time to complete your business execution completely. Okay. So in processing area, again, those things will come. Now, my requirement is I want to change the replication factor from 2 to 3. Currently, my replication factor of this file is 2. I want to change it to 3. Do you have any command available to change this replica from 2 to 3? Of existing file, okay, remember. So this is my command, Hadoop or HDFS, and I can run this from anywhere. I can run this command from any slave node or any master node also. Currently, since master is with me, I will use master machine to communicate. But if you have a curiosity that how can we run from slave also, I'll run one command from slave, and you'll see the same thing can run from a master along with slave. HDFS DFS title is this: change replication factor of existing file. Command is HDFS DFS minus set rep, set replica minus W. So currently it is 2, right? Let's say you want to make it 3. So you'll give 3. And then you'll give what is the file name? Sample.txt. So this will change the existing replica, which means currently your data is copied in two machine, DN2 and DN3. Maybe it will copy to DN1 or DN4. That we'll see once we submit this command. We'll again go there, we'll validate whether this machine is having a block or this machine is having. But this is a command to change the replica. You can increase or you can decrease. You can make it 1 also from 2. You can make it 3 also from 2 using setrep command. So one question, does this command only work for the file which is already present in HDFS? No. If you want to copy a file with actual 3 replication factor, okay, in Hadoop, you can use the sim command. I'll use for both. First I'm doing for existing file, then I will do for new file. Change replication factor for new file. Command will be exactly same. Let's do this first, then we'll go for next one. HDFS DFS minus set rep minus W3, and what is my file name? Sample.txt. Again, remember this command can run from any machine, not specific to this worker or any master. From anywhere I can run. Done. Now, can I check it? HDFS minus ls slash. This represent my number of replica. So can you see the replica is 3. By default, permission of this file is 644. This is the owner of the file. So currently my username. This is the group of your group name of your uh, file where this user belongs to, and this is your file, actual file. This is the size of it. This is the date of it when I have copied it. Now, can we go and re-verify again where this actual file is stored? So, two locations already I know. This is present in DN2 and DN3. I'll check on DN1 and DN4. So this is DN1, W0, data node 1, CD, Hadoop, DFS, data, current, block pool, current, finalized, subdirectory. List it. It's not there. No 59 bytes, which means for sure this is present in node number 4. And node number 4, I think this is my node 4. Yeah, this is my worker number 4. So CD, and I'll just copy this to save our time. Paste, finalized, subdirectory. This is the block, guys. This is the replica of it. Metadata of it. If I want to replicate it multiple times, what will happen? If you see cat in this block name, you can see the data. Now, after changing the replication, the same A block is present in this machine, in this A machine. Okay. So now I have replicated my file. I have changed my existing file replica. Next one, can I do the same thing for new file? We'll try it. This command I will run from master. This is my master machine. HDFS DFS minus ls and slash. HDFS DFS. Now I have changed it from 2 to 3, so I'll do this time one replica only. Okay, I'll check it for only one replica and say HDFS DFS minus setrap minus w is equal to 1 space. What is the file name? Sample.txt, and I want to copy this with name s1. Enter. One second, maybe I need to give minus put. Okay, so let me put it first in HDFS. HDFS DFS minus put sample.txt s1 underscore new. HDFS DFS minus ls slash. Now the current replica of this file is 2, which means this is present in two different machines. It can be worker node 0, 1, 2, 3. Now I will change this from 2 to 1. DFS minus setrap minus W is equal to 1. What will happen? It will delete one replica from one machine. If you're decreasing the replica, it will delete the file from one machine, sample.txt. You can see the warning also. The waiting time may be long for decreasing the number of replication because this will delete the file. Again, DFS minus lsn slash, you'll see now one replica for that file, which means this file is only present sample.txt. I think I ran for this file. Yeah, sample.txt. So this is now present only in one machine now. It has deleted from two other machine. This is how you can change the replica of your file. One last thing for today, we'll check. How can we increase or decrease the block size? How can we customize the block size? Okay, how can we customize? So this is not working for new file. This is only working for existing file. Customize block size. By default, it is 128 MB. But let's say you want to change from 128 to some other number, 150 or 256 or maybe 200, any number you can check, 100 MB. What is the command but to customize the block size? For that, first I will download a file. Hadoop download. Index core. I'll get it anywhere. So let's take 2.9.2. This is bigger, I think, 349. Do we have any big file? This is just 186, 126. Okay. So 2 blocks it will give me. Basically, I need a multiple blocks to understand the distribution. That's why I'm copying it. I'll download this in master machine. What is the command to download? wget and paste. Wget stands for webgate. So whenever you want to download anything, you'll give this wget. Enter. Again, this will take hardly a minute to download. Clear this. LSLRT will verify the size. du-h Hadoop. This is the size of file. So I want to change this by two different uh, different blocks. So 187 MB, if I say, can I change this 187 MB into let me take this value. Okay, done. So 187 MB is done. File is copied, and I'll re-verify using HDFS DFS minus lsn slash. It has copied only in two different machine. Okay, because replication is 2 and distributed only once. So distribution, if you want to check, we can go to uh, this is worker 2. So do we have any file here with the size of that? It does not have. Do we have any file here? LSLRT. This has the size, guys. If you do du minus h and this name, you can see the size of block. You have changed it, customized it, and changed from 128 to 187. The same copy we will have in one more machine, which can be DN2 or DN3. So this is my DN2, use LSLRT, sorry, CD. I'll go to this folder. This also does not have, which means for sure this machine is having. What is the replica? So it is in W3. Looks like I have overwritten the file. LSLRT. Okay, this machine is having. So this is W0, worker node 1. This is my block. If I check the size of it, du-h. Okay, so this is two things we learned new, how to change the replica of existing file and how to customize the block. Okay, and why customization will come, we'll see in the processing area. So this is pretty much your multi-node cluster.